the memory allocation topic, and we saw what were the two types of memory allocation: compile time and runtime, that is static time or dynamic memory allocation. So we saw a few disadvantages of the static or compile time memory allocation, right? And in order to avoid those, uh, we opted for dynamic memory allocation, right? In order to use dynamic memory allocation in C++, we have the keywords new and delete. New keyword used to allocate some space, and delete keyword obviously it will relinquish or it will deallocate the space which was allocated by the new keyword. Okay, so new and delete are considered to be two operators, right? And suppose we have declared an integer pointer like this, int star point var. So there is a pointer point var, right? And it points to the address of some integer variable, like maybe a. Its address supposes 1000. So its address is stored by this pointer, right? Now remember one thing, whenever we create a pointer uh, in CPP, we have to allocate some memory for it, right? So how do we allocate that memory? By using the new keyword, right? So an integer type of memory is allocated. Why integer type? Because we made this pointer with the type int. So it can always point at some integer type of memory. An integer pointer will never point at some another data type like float or a double. It will point to the address of a variable which is of the same type. Understood? So that is how it goes. Now, suppose we want to assign some value. Okay. Okay. Let me give you a small example of pointers now. Be uh, very focused. If I have a variable a to which I have assigned a value 5. Okay. So in the memory, a will be created with the value 5 and a might have some address as 1000. Fine. Now I create a pointer of the type int. Name of the pointer is p, for example. Fine. So a pointer got created and its name is p, and it might have been created at any memory location, maybe 1002. Fine. Now I say p is equal to address of a or reference of a. Why this is possible? Because p is a pointer and it can hold an address. Which type of address p can hold? Int type of address, right? So a is of int type. So I can say p is equal to address of a. That means a holds the value 5 and is present at which location? 1000. P is a pointer variable which holds the value 1000 because it carries the address of A. So it points to the A. And its own, where P got created, its own address is 1002. Clear? Now, if I want P to point at any unknown location which is newly created. Now this A was created with, an integer location was created whose name was A and whose address was 1000. If I say P is equal to new int, that means I'm making P point at an unknown location. Now P is pointing at some unknown location, unnamed location, I would say it as. But is it of the same type? Yes, int type. So I'm reserving a space of integer type and then I'm making P point at that location, whichever location I have reserved. Understood? Clear? Here the difference was I had a name for that location. The name was A. Over here, where P is pointing, in this case, this location is not having any name, but it is having some address. Let us suppose it is 1008. Right? So what P will hold in this case? P will hold 1008. The moment this memory got reserved, the address of that memory location is returned and P stores that address. Got it? Yeah.
Yes.
Okay. Now this memory location, which we named as A, had some value, that is 5. Now, the memory location that I have created dynamically with the new operator, I want some value to be stored at that memory location. So how do I do that? I have to say star P is equal to, suppose, 10. Star P is equal to 10. Now remember that whenever I declare a pointer like this, star is used to depict that it is not a normal variable, but it is a pointer variable. Okay. If I don't use this star, P will be a normal integer variable. Fine. Then after the declaration step, whenever I use star along with P, what I am referring to? I am referring to the contents present at P. What does this star represent? It represents contents at P. Now what P shows, what P carries? P carries 1008. So that means contents at 1008. What is the content at 1008? Nothing right now. So if I say star P is equal to 10, that means contents at 1008 will now be what? 10. Understood? So I'm accessing the value through a pointer. Here also, if I, in case of this A, if I would have um, said maybe C out star P, that means display contents at P. So which value would have been printed? 5 would have been printed. So instead of saying C out A directly, I am indirectly printing the value of A through the pointer I am trying to print it. Is it clear? Here there is no question of accessing the value of the new memory location directly, because does the memory location have a name? No, it does not have a name. It is unnamed. So the only way to access this memory location may be to access the current value or maybe to modify the current value. The only way is to go through the pointer which points at the memory location. Is it clear? The type of memory that you are reserving should be the same as the type of the pointer which will store the address of that newly reserved memory location. Okay. That is important. So we discussed this, that the new operator will reserve some space and it will return the start address of the new memory location, and it is stored in the pointer point where. Okay, so this is clear. So the memory which is allocated externally should be deallocated externally, right? So the use of the delete operator is to do the same. Whatever memory is reserved, we are able to deallocate that memory with the help of the delete operator. Fine. So uh, yeah, if we were to delete, so it would have been point where, delete point where, the pointer variable that we created earlier. Yeah, the same thing. We have declared a pointer. We have allocated memory to the pointer dynamically. We are assigning some value to the memory that we created dynamically. We are trying to print the value by saying star and the pointer name, and then we are deallocating the memory, right?